Hello, everyone, and welcome. I'm so happy to be here. Thank you for the organizers for putting this together and inviting me to this conference. It's my first time attending, but I had heard about it, and a lot of people don't say thankfully because of COVID, but thankfully I will be able to attend this year because it's remote. So, thanks for being here. This is my talk on it's not a vulnerability, it's a feature. And I wonder how many of you have heard that before. I've heard this quite a bit in my past 10 or so years doing offensive security, doing ethical hacking, and I have a little proposal for you at the end, a way to make money and make that feature into an even better feature for you. So my name is Jorge Orchilles, and I am the Chief Technology Officer at c0c0n. I joined about 3 months ago. Prior to that, I led the offensive security team at Citi, Citigroup, the global financial. I started there as a vulnerability assessment analyst, built out the penetration testing function, created the red team about 5 years ago, and also started doing purple team engagements in collaboration with our blue team and our cyber threat intelligence team. It was a lot of fun. Things I've done to give back to the community. I have a project with Bryson Bohr and Adam, and really a community project called the C2 Matrix, the Command and Control Matrix. I've also published a free framework called the Purple Team Exercise Framework for you to learn and do and follow a Purple Team exercise flow and hopefully bring that same value to your business as other functions in ethical hacking. I'm a SANS certified instructor. I teach Security 560. I'm actually teaching this week Security 504. So if you have the GCIH or the GPEN, shout out to you. I'm also the author of a 2-day red team exercise and adversary emulation course at Security 564. Other things I've done is I was part of the working group and a voting member for the Common Vulnerability Scoring System, version 3 and 3.1, which is the current version. Also wrote with the Global Financial Markets Association a threat-led pen testing framework for the regulatory use of ethical hacking in financial institutions so that they can gain their regulatory requirements globally. I'm a big believer in ISSA, the Information Systems Security Association. Was actually honored to be named a fellow there, as well as the National Security Institute. I'm a technology fellow there. So that's me. That's my experience. And this talk is really where I think the ethical hacking space is moving to. I think we have done a fantastic job in creating bug bounties and identifying vulnerabilities. And many companies have those bug bounties. But what do we do next? So to get to it, and in the simplest form, we have the internet that we're all connected to, right? Millions and millions of people. We have bad people. We have good people. And the bad people are trying to get us and get inside of our networks and cause impact. So how do we go about securing that? Well, when we look at an attack, and in the most basic form possible, we have reconnaissance, where we learn about the target. We have initial access, which is how we get into that environment, right? And today we see that shift right into systems that are remote, but yet we can still get access to those remote systems. And then from there have access into internal networks, and then move laterally and do post access. So a lot of the focus has been on this recon part and on initial access, right? If you look at bug bounties, that is mostly focusing on access, right? Finding a vulnerability and exploiting that vulnerability. And then, of course, reporting the vulnerability so that the vendor knows about it, they can patch it, and you have just made the community better, you've made the product better, you've made their customers better, and that's great. But we've seen a lot of focus here, right? We also have really gotten better at securing our perimeter, right? We're using all these great firewalls. We're getting scanned from the internet all the time, and we've actually done pretty well. But then over on the right, we have post access, and this is really what our focus has been for the past few years now. Many of our assessments and how we work is starting to focus on post access, because in post access, you only have a limited things of what you can actually do. So that's really where we're going to start talking about in this session. So how do you get in? There's two main ways in, right? From when you do reconnaissance, you either find a vulnerability in a product and you exploit that vulnerability and you gain access. That's great. That's pretty much the entire bug bounty spectrum, is on doing reconnaissance on some organization that does bug bounty and finding a vulnerability and reporting it once you exploit it. And that's great. There's many ways to monetize that. And that I don't think is going away, right? Because we will continually find ways in, and there's going to be a lot of these ways in. So if you're part of bug bounty, that's awesome. We're all on the same team. And then there's people, right? There's always going to be that weak link of a person that has access already, whether they're a malicious insider, whether they're a negligent insider, or whether they just made a mistake and they have fallen for a phishing campaign and clicked on a link or executed something that got sent to them, right? Like, there's a number of different ways that this could happen. But at the end of the day, there's always going to be people. Someone's always going to click on something. I'm sorry to tell you that. One of the things I've done is built social engineer awareness programs where we actually send phishing emails, and we had about 200,000 staff that we would send emails to all the time. And while we would get pretty good, the more you test, you would still have maybe 5% of the folks clicking, right? And 5%, when you look at 200,000 people, is still a lot, right? And at the end of the day, it only takes one. So unless you know something I don't, there's always going to be the people problem that's going to gain you access, and there's going to be the technology problem that, of course, you're finding vulnerabilities with your bug bounties or in your ethical hacks against your organizations. So this is our mandatory MITRE ATT&CK slide. Our lawyer said if we remove this, we could actually get sued. I'm just kidding. But this is MITRE ATT&CK. I'm sure you've all heard of it because it's the industry standard, right? So MITRE has done an awesome job, right? We have the common vulnerability and exposures from MITRE, right? CVE.mitre.org. That is where we have the initial access sort of stuff, right? That's where you find a vulnerability, you report it, the vendor creates a CVE, and you have a CVE to your name. Great job. Congratulations. That's awesome. But then MITRE came out with ATT&CK. ATT&CK stands for Adversaries, Tactics, Techniques, and Common Knowledge. And it really is a common knowledge, or a common language that allows cyber threat intelligence to speak to blue teams, to the defenders, and to also speak with the red team. So we can all speak the same language. And MITRE ATT&CK is quite interesting. Here you can see all the tactics at the at the top, those are the attacker goals. And this is actually a screenshot of Attack Navigator, which is one of my favorite tools. It's free. And what I did here is I did a search for the word exploit. And in the 184 techniques that MITRE ATT&CK has, only 6 techniques are related to exploitation. So let that sink in, right? Only 6 techniques are related to exploitation. I have 184. And then over on the left, we have the tactic of initial access, which is what we've covered. This has been the focus of the industry for the past 20 years, right? Preventing, patching your system, find a vulnerability, patch, find a vulnerability, patch, find a vulnerability, patch, right? And there we also have things against people like phishing. Phishing has 3 sub-techniques, and you can phish people. And as I mentioned, there's a bunch of ways in. But that's only 9 techniques. What about everything else? Everything else are actually features of products, right? Most of them are going to be features, and you can't really prevent those. So as organizations mature, they should, of course, do vulnerability scanning. They should, of course, do patch all those vulnerabilities, do vulnerability assessment, do penetration testing where they find vulnerabilities and exploit those vulnerabilities, right? And then we're getting to a point where many organizations are doing red team engagement. Many organizations are doing some purple team where the red and the blue team work together, and are doing adversary emulation where you understand how an adversary works. And what you'll see is that most adversaries just use one initial access vector, and then the rest of the focus is on all these other techniques. And these techniques, as I mentioned, are not patchable. You have to build detection. So if you're a bug bounty and you find vulnerabilities, great, they patch them. But what if you find a feature? What about those? Well, now the company that is on the other side, and unfortunately we have to do this per company, they need to, one, test these features and see if they can detect them. And that's what we're going to focus on today. So post-access. You have gained access in one of many ways, right? I think that is extremely clear to everyone at this point. You phished, you exploited, you did, one of those 9 techniques, and now you have access. So what happens next? Well, of course, we have our Elon Musk there that's super smart, but might do some dumb things, right? We have our not so smart internal user that could have fallen for something. And of course, we have our nation state spies that have that internal access as well, right? And this could be a perception of what your internal users are, or this can also be your attackers. And they are going after your valuable information, right? That is the whole point of getting in. Even today, when we see the various different attacks, what are you seeing out there? You're seeing a lot of ransomware. And what are they doing? They are grabbing your information, your valuable information. They're encrypting it, they're exfiltrating it, and then they are either ransoming or extorting you and saying, either pay us money or your information, either 1, becomes public, or 2, we delete it all and you can't work, right? And that has a value. And that's, at the end of the day, what you are trying to protect. So what we propose here is that once you gain initial access, there's 2 verticals that you need to focus on. One is communication, right? And we've done a lot of work here with the command and control framework to show the various different communications that you can do. The command and control framework covers various channels. The most common one is HTTP, right? Because most organizations allow HTTP outbound, right? Your users have to be able to go to the internet. So HTTP is probably the main communication channel we see, but there's others, right? There's DNS, which is also required for you to access the internet, right? If you're going to go from a domain name to an IP address, you have to allow DNS. Now we have DNS over HTTPS, right? There's a bunch of other communications, right? There's standard TCP. There's HTTP2 and HTTP3, which you might not be looking at. There's FTP, right? I was actually just looking at one threat actor that used FTP as a communication channel. That was an interesting one to emulate. But that communication is limited, right? So what do? You have to learn how to detect that. So you as an attacker are going to use these channels, these HTTP and anything that's allowed outbound, and you're going to test those. And because it's allowed, you can't block it. You can't block everyone's internet access, right? You need to figure out how to detect it. How can you detect what is good HTTP traffic and what is bad HTTP traffic, right? You have to test it. And every organization is going to have to test this to identify those abilities of communication. And then the second part is capabilities. And capabilities are what you can do once you are in and you have established that communication channel, right? So if we go back to MITRE ATT&CK, we see that there is command and control. Command and control would mostly be the communication channel. So we've covered initial access. We've covered command and control. Now everything else is capabilities. The capability to execute code, to evade defenses, to escalate your privileges, to move laterally, to dump credentials, to exfiltrate data, right? All of those are capabilities. And really, that's quite a bit of techniques that we can do. And those capabilities are generally allowed by the particular operating systems that we are using today, because that's how the functionality works. So we also have our defensive triage here, right? We have protection, detection, and response. So protection, again, focuses on the preventive controls. This is blocking the initial access, right? And there is a ton of market for this. I don't think we've resolved the issue, but I want this to be a forward-thinking talk, right? We see these next generation firewalls, right? And this next generation antivirus and anti-exploit, right? Your silences and your crowd strikes and all these tools that focus on prevention, right? But at this point, I think you can propose to most large organizations and really anyone that's watching the news, right, that somehow you're going to get around those protective controls. And I'm in no way saying don't focus on protection. You have to, right? You have to have some prevention. It's not like you're going to leave all the doors of your house open and unlocked, right? You are going to still close them. You're still going to lock your doors, but you are going to assume that a capable actor that has the opportunity and the intent to attack you will eventually get in, right? That's the whole P in advanced persistent threat. They're persistent and they're going to go and get in. So what do you need to do after that protection is set? You need to do detection and response. And detection and response is an area that we have not standardized on yet. And that is because everyone's internal network is different. And we see this all the time. We see someone trying to take our product, Scythe, and I'll talk about that shortly. We create synthetic malware on the fly. And when you create this malware, a lot of times it gets around those protective controls because there is no signature for it, right? We're creating it right then. And then in a lab environment with all of these things turned on, you get caught. And that's great. That's actually good. The problem is that in a lab environment, you have everything turned on. And when you go to a production environment, you have to turn off a lot of those detective and preventive controls because your network and your internal systems actually do a lot of this, right? PowerShell is an example. People trying to just block PowerShell.exe, and then they realize that 8 different production tools actually use PowerShell.exe to do something, right? I was on an engagement just last week where we were turning on detection for PowerShell.exe, right? Rarely shouldn't really be used. We asked the target organization, do you use it? No, we do not use PowerShell. Perfect. We turned on detection for it. And within a couple hours, we had all these alerts, and we're like, yeah, you use this Dell product, and this product uses PowerShell, and you use this other product over here, and look at that, it uses PowerShell. So turning things on and detecting in a production environment becomes a lot harder. And what does the defensive team have to do? They have to tune it. And this is where we are proposing that you test each of these organizations so that they tune their defenses to detect malicious activity. And then, of course, you have the response to that activity. What happens next? You had a trigger that PowerShell.exe, just to keep that example going, was executed, and it's not on the 8 different production tools that you have. So what is the response now, and how can we focus on that? So one of the capabilities here that I want to talk about is called LOLBAS. This stands for Living Off the Land Binaries and Scripts. And there's a great site and a project here. It's lolbas-project.github.io that brings all of these together. There's 119 of them currently documented. And to be a LOL bin library or script, so a binary, a library, or a script, it needs to be signed by Microsoft. So either native to the operating system or downloaded from Microsoft. So the example I give here is sysinternals, right? Everyone's heard of PSXEC. You can download PSXEC, it's signed, and it will most likely execute in most Windows environments. And then they need to have some sort of extra or unexpected functionality, like the ability to download from the internet, or the ability to execute something, or the ability to hide something, right? And most of these are going to get around application controls, because when you do application controls, again, it's not something that you just turn on. You actually have to turn it on for various things. So sure, you don't want to execute this random executable that someone downloaded from the internet, but you have to execute Windows signed binaries because they're used for other things, right? And then lastly, have the functionality that will be useful for any PT. So let's dive into an example here. And one of my favorites is run DLL32. Run DLL32 is used by Windows to execute DLLs. And a DLL is a dynamic link library. The way that the Microsoft operating system works is you have an executable. That executable can leverage DLLs as shared code. That way you don't have to recode everything, right? At the end of the day, it makes sense. And it's something that you can't remove, right? It's part of Windows. It comes in Windows System 32. And even though the name says run DLL32.exe, you can actually run 32-bit and 64-bit DLLs. So here's the example of it from LOLBAS website. You see the resources there. There's a number of articles that have been published on it. There's acknowledgement to a number of industry folks, and thank you all for that work and giving back to the community. And then on the right here, you have various different ways of executing and how it executes, which is nice. You can even execute it from an SMB share, right? So we'll dive into this example shortly. Now, one of the reasons that I'm going to talk about Scythe, I do work at Scythe, and it's an enterprise-grade platform for adversary emulation. And the reason I'm introducing that is because the module creation and the SDK and the bounties that I'm going to present are going to be for this particular product, but you can use them for others as well. So if you haven't heard of Scythe, what we do is it's a platform for creating custom, controlled, and synthetic malware. It's like WordPress for malware. It's very modular. You can go in and select what different behaviors you want to do, what different TTPs you want to run, and it creates this executable that you then run in the target environment. Most of the time, it's not getting caught by security controls. And that's the whole point of it, is to actually test and work with the blue teams to identify these blind spots. Right now, these are some of the features that it has, but what I'm proposing here is the ability to create other capabilities and other communication modules. So we mentioned command and control, right? And in our case, built into a product right now, we have HTTP and HTTPS communication, which is obviously the most common, DNS, SMB for lateral movement, Google Sheets. So if the target organization uses Google Apps or Google Sheets, we can actually use that for command and control, which is pretty cool. And it emulates an adversary known as c0c0n, one of those fin groups. Pretty cool stuff. We also have Twitter that allows you to change your C2 servers. It's another pretty cool module, as well as steganography. So you can hide your command and control inside of images. And then one of the main things I haven't mentioned yet, apart from being an enterprise command and control, is that we have automation. Now, when we pick a particular threat actor to emulate, we don't just run one TTP. We chain these together. And I think that's extremely important when you start working with blue teams, because maybe running who am I isn't going to trigger a response, right? Because who am I is something that everyone runs, right? But maybe if you run who am I and ipconfig and then take a screenshot, then maybe those three combinations happening very close to each other, maybe that should be alerted. So what we try to do is bundle these together, right? There's a number of delivery methods for this particular executable, but we're very much of an assumed breach. And then, of course, there's reporting and integration, just like any enterprise product would. We, in particular, integrate with things like Vector, which is an awesome, awesome tool. I have a whole hour-long talk about using Vector for tracking and showing value of red team and purple team exercises. We integrate with other solutions like PlexTrack, with SIMs, so that you can send your attack information to Splunk or any of your SIMs. And we have all of Atomic Red Team there as well. So the whole point here, the reason I introduced that is because it's modular. So we have released the latest version at Black Hat DEF CON just a few weeks ago. And there's a few key differentiators that will make sense of why I'm bringing this in. And one of those is that everything you run in Scythe runs in memory, very much like your malware that you're finding out in the wild. And that is for detection purposes. But from there, once you are running in memory, a lot of other malware is trying to pull and run other executables and things like that. What we do is we load everything into memory and then run it there. One of the new things that we do that I don't think anyone else does is that we can load the Python 3 runtime into memory. So you don't need Python on the target system to then execute your Python code. And I know a lot of you like Python, and that's one of the main things that you'll be using here if you start creating modules and try to sell sell those modules. It has a virtual file system. This is more for red teams to work together, right? It puts the team in red team. And the threat automation language is when you automate things, you want to have some sort of logic built in. So for example, run a who am I, or figure out what access you currently have. And if you don't have the access to run mimikatz, why would you load it into memory and run mimikatz if you don't have to? So you can figure those things out and create that logic. So the architecture here, and this is how it works. You have the marketplace and community. That's all of you over here on the bottom left. You use the software development kit, which I'm going to show you. It's completely free. And we leverage cyber threat intelligence to create modules, right? So if you've heard of a new TTP, a new exploit, whatever it is you want to create a module for it, you do that. You put it in the marketplace, and then anyone will be able to take that, whether you do it for free or for a price, and they'll be able to create campaigns. Those campaigns are then executed in the production environment. They go through their automation, the SOC and the blue team see if they caught it, and then you can do this over and over and over again. It's pretty cool. So what we are proposing here, and what I'll show you in a little bit, is a marketplace. And the marketplace is a secure ecosystem, right? So just like bug bounty, where you get vetted, that's the same thing here. If you're going to create and sell things on the app, on this kind of app store type of feel, then you do get registered. And of course, if you're going to get paid, we kind of need more information, right? And it's like a Google Play Store-ish, right? So you create a module, you put it in the marketplace, and then you can put it there for free, just like normal apps. So just like many mobile apps, or you can sell it. And then module developers, all of you would create new modules, and that really allows us to drive the bleeding edge, right? We get to have new things added without having to wait for a product update. So that removes burdens of customer validation. It is invite only. So customers and vendors that use Scythe, and it's bug bounty friendly. And we're going to actually announce some bug bounties right now so that you can create some of these and make some money. And then we have the SDK. You don't need to have Scythe to use the SDK. The SDK is fully, it's free. And you can create modules in native code or in Python. And that's why we created that Python runtime, right? So you can actually create a module in Python, load it into memory, and get it executed on the target system, regardless of the target system even having Python. So I think that's pretty cool. And the SDK is on GitHub. We have a module buster, GUI. And apps are side loadable, so you can actually share your source code if you want. You can post on GitHub. In that case, we're not, stopping anything. You can put it wherever you want. So if you create a new module, you can actually post it somewhere, and people can download that and side load it into their Scythe instance without going through the marketplace. Of course, we think you should go through the marketplace. So this is what it looks like. It's marketplace.scythe.io. And you see some of the features here, like Chrome Cracker. Chrome Cracker will go onto an endpoint once you deploy Scythe, and it'll steal the passwords within Chrome and decrypt them. So you know how people save passwords in Chrome. There's also one that steals and decrypts the cookies. So if you have a number of cookies in Chrome, I'm sure you have thousands of them, we can grab those. There's LMO, which is let me out of your network for testing egress. There's YaraScan, and there's a few others in development that will be posted shortly. So we just announced this, right? So why am I telling you this? And it's because you will hear quite a bit when you're doing your bug bounty and you're finding vulnerabilities. It's not a vulnerability, it's a feature. So at the end of the day, you've kind of already done the work, right? You already found that vulnerability or that feature, And now the bug bounty vendor doesn't want to pay you for it. So what do? Well, you can create a module for this feature and put it on your GitHub or put it on the Scythe marketplace or both. And you can also try to sell it for some money. Now, we don't know how much these modules will cost, right? It's a new thing that we're proposing here. So it's really to let the market see what it will be. But at the end of the day, even if the money isn't that much, we think it will be, we are building something new. And we've already proved that we can make ecosystems in offensive security around bug bounties, right? So why don't we do it for these techniques, right? So really evolving from common vulnerabilities and exposures from those CVEs that focus on initial access to tactics, techniques, and procedures, which is what happens afterwards, right? And I'm not saying stop doing CVEs. I'm saying we are evolving and maturing and doing both. So what I want to announce here today is we have some bounties out. We have 3 that we are putting out. They each pay $2,500. And one is a communication module, the use of Office 365. And yes, there are some proof of concepts out there on the internet that you can start with. And then capabilities modules, things like escalation of privilege and persistence are the ones that we are bountying out today. And of course, I want to show you some of this stuff. So let me jump over to our demo over here. So LOLBAS was one of the first things I mentioned. This is living off the land binaries and scripts. And look at that. It has already been updated to 125 different ones. And we can scroll through here, or we can search. And here's the run DLL 32 that I talked about. You can see various different ways of running and executing run DLL. And I want to just demo that for you because it's pretty cool. So let me log in here. We're going to log into Scythe, and we're going to create just a quick, very, very quick demo. We're going to create a new campaign. Here we have our name of the campaign. We're going to run on Windows. We can restrict it, so we can actually put execution guardrails into our payloads, which means they can only execute in a particular environment. In this case, we're going to use HTTPS. Here you can see some of the other communication modules I mentioned. And we are creating this on the fly. So we can specify a PDB path, and we can specify and randomize our compilation timestamp for the future, right? When you will watch this will be what, September, I think 19th. So we're going to create that. Here's where we can choose a whole bunch of different modules. Here's where I can insert the Python 3 runtime straight into memory. We can also do other things like steal from the clipboard. It's just as easy as clicking these. So I'll do it very, very quick. And at the end, we'll get a shell. So here's the logic that you can add that I mentioned. And these are all modules up here, by the way, that we've created, but you can add others through the marketplace. So I'm just going to start this campaign. And what I'm going to do is do the run DLL 32 execution. You see it took a few seconds there. That's because I just created this. So it just created this run DLL 64-bit DLL. I'm just going to copy this. I'm going to download it. And we're going to open up a command prompt. Go into downloads. There we go. You run DLL32.exe. We called it this. And then the way run DLL32 works is you have to give it the starting point within that DLL. So we click on that, and then hopefully it connects here in a second. And there we go. There's Georgie P1. So I now have a shell onto this machine. I can load other modules and perform a number of different techniques and whatnot. But as you saw, I downloaded it. Chrome gave me a little warning because it's a DLL file, but it has ran its through run DLL. I can then close this and I have my shell. The other things I want to show were the actual marketplace, where some folks have already created some things. This is the Chrome Cracker one. If I were to download and install it in that previous screen, you can see Chrome Cracker. We would load that, and then in our shell, we load the Python 3 runtime, and then extract those saved passwords. To get started, we can just go to scythe.io/marketplace. Here, we tell you all the benefits of doing this, of why you would want to do this, and how to get started in it. It involves downloading our SDK, which, as I mentioned, is free, and you can just grab it off of GitHub. And as long as you know Python or native code for Mac, Linux, or Windows, you'll be able to get started. So from a graphical representation, how do you get started? You get started by downloading the SDK. You set up your development environment. You review sites, example modules, and testing suites. We have a number of blog posts on how to do that. Then you develop your module. You complete the Scythe Marketplace schedule. You submit your module, we review it, and then it gets published to the marketplace. Pretty cool and pretty neat way of sharing TTPs with the community and hopefully get you some money. So I do want to leave you with a try it yourself thing. This is a choose your own adventure. I'm sure many of you have played this before. You remember the books, right? The choose your own adventure books. We've created a red team one, right? And most of this is post access. So if you go to scythe.io.github.io/CYOA-red team, you will be presented with a choose your own adventure game where you read through and then you can choose what post exploitation processes you want to run and see if you make it through, see if you're a successful red teamer or if you get caught by the blue team. So that is my talk. I think I'm within the time frame here. I really appreciate your time. I think we presented something that will make you think about the future of where we're going as an industry, and hopefully get you to work on some capabilities and communications and really monetize whenever you hear that's not a vulnerability, that's a feature. Say, oh yeah, here we'll create a module and then sell in, allow organizations to test themselves to see if they can detect that feature. So thank you again for your time. I'll take your questions on Discord.